Imagine you're working on a project, and you need a third hand to help you out. Well, you don't have to imagine anymore, because there is a bionic arm that can do just that. Hey, welcome to my channel, where I share with you the awesome and most surprising stuff in automation, discovery, and invention. In this video, I'm going to introduce you to the Bionic Soft Arm, a flexible and versatile device that can adapt to different tasks and environments. So, are you ready to see what this arm can do? Let's dive in. Bionic Soft Arm. Collaborative working spaces of the future. The work ranges between the manual work of the factory worker and the automated actions of the robot are overlapping and merge into a collaborative working space. In this way, humans and machines will be able to work together on the same workpiece or component simultaneously in the future, without having to be shielded from each other for safety reasons. Pneumatic lightweight robot with natural movement patterns. Like its two predecessors, the Bionic Handling Assistant, 2010, and the Bionic Motion Robot, 2017, the Bionic Soft Arm is a compact further development of the Bionic Motion Robot. This is made possible by the modular design of the Bionic Soft Arm, which can be combined from several pneumatic bellows segments and rotary drives. Depending on the requirements, the length of the Bionic Soft Arm can be varied, with up to 7 pneumatic actuators. This allows the Bionic Soft Arm to work around obstacles even in the tightest of spaces. Technical implementation. Depending on the desired action, the bellows can bend freely and stiffen as required. For this purpose, they are sheathed with a special 3D textile knitted fabric that allows expansion of the bellows structures in the desired direction of movement, and simultaneously limits them in the other directions. Intuitive operation via tablet. With a tablet, the user can easily teach the robot the actions to be performed, and set their parameters. The commands are implemented by a Festo motion terminal (VTEM), which is what makes it possible to control and adjust the complex kinematics in the first place. The open-source ROS platform serves as the interface between the tablet GUI and the Festo motion terminal, and is used to calculate the paths of the kinematic system. Hopefully it has been helpful to you. You can watch the rest of the videos in this playlist, or better yet, subscribe to this channel so you'll always be aware of new content.